Hello, hi, welcome to this brand new session of Summer Series brought to you by Khan Academy. Now, here I am very excited to bring this series to you, and I know you guys are very excited as well, right? Now, I can see your chat windows right here. So, quickly tell me, everybody, if I'm properly audible, properly visible, no tech glitches anywhere interrupting us, okay? Now, can you tell me? I can see so many people are here. Aditya is here. Masti with child is here. Okay. Chakri is here. Hello. Hi, Chita. Hi, Santosh. Hi, Saika. So, quickly tell me, everything good? Kuch, is there no problem at all? So, I will go ahead. Okay. And keep telling me, where are you guys from? Yes, I can see that. Everything is clear. You are able to hear me. You are able to see me. So let us move on. Yes, I can see Radha. Thank you so much for that confirmation. So let's move on to our session now. All right. Now, first things first. Summer vacations are so much fun, right? But then we thought at Khan Academy, why not make summer sessions fun with math, right? So, in between of all the musty that you do during summers, we are here with adding math to that musty and we'll have fun with numbers as well, right? So, let's go ahead and let's take a quick look at the schedule right here, right? But before you know me, before we move forward, anybody who does not know me yet, well, let me tell you a little bit. I am Anushri. I'm an IIT Kharagpur graduate. I have been teaching math and physics for competitive exams like IIT JEE and NEET for the past 15 years. And I love teaching you guys because I love seeing you guys crack the concepts and then work hard and work smart and crack the exams as well, right? That is exactly what we all want here. So let's quickly go ahead to schedule of English sessions here, right? Now, these sessions will be conducted throughout summer every Saturday. So, Saturday morning, Saturday afternoons, keep open because for grade 6 to 8, we'll be meeting 11 to 12 exactly on Saturday. And for grade 9 to 12, we'll be meeting 12:30 sharp. All right. Now, some of you might be wondering, all right, ma'am, we might be 11th grade or 12th grade or 9th grade or 10th grade. How are you starting these sessions? Let me make it very clear to you that if you understand the basics of mathematics, you will be able to build on top of those foundations very well, right? So let's go ahead and start because all of you know the foundation for 11th grade is built in 9th grade and foundation for 12th grade is built in 10th grade, right? Tell me if I'm right or not. Tell me if you agree or not. All right. I can see Chita is here from JNV and oh, Kanyakumari. Hello, hi Kanyakumari, hi Dilip, hi Pinky. Hello Rashmita. All right. I can see everybody is very excited here. Oh, we have JNV from Jodhpur also and JNV Gomati. Okay. And JNV Faridkot. Awesome. Okay. OAV. How many of you are from OAVs? I saw so many JNVs out here. All right. I can see, okay, yeah. Oh, JNV people are winning right now. There is JNV Nault, JNV Rudapur. Okay. Oh, Disharth. Dasharth is there from OAV. All right. Hi, Dasharth. And then we have JNV Muktsar also. Okay. Oh, OAV Gola is here. Okay. Now OAV people have started telling me where they're from. Yes. So let's move on. Let's get to Khan Academy website. And till now, if you guys did not know this, let me tell you very quickly that all the content that is there in Khan Academy website, all the videos and the exercises and the quizzes and the worksheets, everything is absolutely free of cost. Okay, there is no paywall behind anything, and you can go ahead and watch fun videos with good clarity and solve questions, everything exactly for free. The only thing that you need over here is your account, right? So the thing that you do is ask your class teachers for your account information. The class teachers will provide the account information to you, and that will be your account only. You can change the password. The password will be only with you. Okay. And then you log in through that account on the Khan Academy website or the Khan Academy app, whichever is good for you. All right. And then you can start learning anything that you want here. Now, another thing is, even if you don't have an account or your class teacher does not have an account for you with the Khan Academy, do not worry about it, because you can create your own account as well, right? But the better thing is to ask from the class teacher, because then that facilitates the class teacher giving you some homework on it as well, right? Some exercises depending on, connected with what you are being taught in class, right? Class में जो भी चल रहा है, that is going to be converted here as well. So you will be completely learning in sync. Exciting, huh? Okay, all right, enough with that. Now, let's go ahead, go to the explore page. As you can see, this is the entire explore page right here. And tell me quickly, over here, is the text visible to everybody? Yeah, the zoom is okay. Is the text big enough for everybody? I created the zoom a little bigger, but I still want to make sure that you are able to see this on your mobile also, if you are watching it on your mobile. Okay. All right. Give me a thumbs up. Give me a sign that everything's good. All right. Yes, exactly. I have got a yes from Apuv and Radha and, oh, Shabani. Okay. Awesome. All right. Let's get started then. Let's get to the first thing here. So, say for example, you are in ninth grade, right? So what do? You go directly to the ninth grade. On the left side of it, you will find the list of all the chapters. You directly go to the chapter that you're interested in. And say for example, today we are doing, yes, linear equations in one variable, two variables, and so on and so forth. And you know what? Solving simultaneous linear equations is one of those skills that is going to help you solving all different sorts of questions, right? It is a skill that is very, very important. In graphs also later on, right? Okay. So let's go to linear equations right here. And here, this is what every chapter looks like. Okay. So what you see here is, first, every chapter out there divided into concepts, right? And then for every concept, you have videos. And then with those videos, according to what is taught in the videos, the corresponding exercises. Yeah, that is fun. So let's go ahead, without further ado. Let's get started with one such very, very good video. Okay. So are you guys ready? You guys ready? Yeah. Okay. All right. Let's get started. Let's get started. Here I'm going to click on the video and you guys tell me if you are able to see the video properly. Okay. And the idea here is that, again, let me make it clear that when the video is running, I won't be speaking, right? Otherwise it gets confusing. Of course it does. So when the video is running, I won't be speaking, but you guys have to tell me that the audio is all good. Okay. There is no problem with video audio. Yeah. Okay. All right. Give me a thumbs up. Yes. Now let us get started. Here I am going to start the video and there you go. And
what I'd like to introduce you to in this video is the idea of a linear equation. And just to start ourselves out, let's look at some examples of linear equations. So for example, the equation y is equal to 2x minus 3. This is a linear equation. Now, why do we call it a linear equation? Well, if you were to take the set of all of the xy pairs that satisfy this equation, and if you were to graph them on the coordinate plane, you would actually get a line. That's why it's called a linear equation. Let's actually feel good about that statement. Let's plot some of the xy pairs that satisfy this equation, and then feel good that it does indeed generate a line. So I'm just going to pick some x values that make it easy to calculate the corresponding y values. So if x is equal to 0, y is going to be 2 times 0 minus 3, which is negative 3. And on our coordinate plane here, we're going to move 0 in the x direction, 0 in the horizontal direction, and we're going to go down 3 in the vertical direction, in the y direction. So that's that point there. If x is equal to 1, what is y equal to? 2 times 1 is 2 minus 3 is negative 1. So we move positive 1 in the x direction and negative 1 or down 1 in the y direction. Now let's see, if x is equal to 2, what is y? 2 times 2 is 4, minus 3 is 1. When x is equal to 2, y is equal to 1. And hopefully you're seeing now that if I were to keep going, and I encourage you to, if you want, pause the video, try x equals 3 or x equals negative 1 and keep going, you will see that this is going to generate a line. And in fact, let me connect these dots and you will see the line that I'm talking about. So let me see if I can draw. I'm going to use the line tool here. Try to connect the dots as neatly as I can. There you go. This line that I have just drawn, this is the graph. This is the graph of y is equal to 2x minus 3. So if you were to graph all of the xy pairs that satisfy this equation, you are going to get this line. And you might be saying, hey, wait, hold on, Sal. You just tried some particular points. Why don't I just get a bunch of points? How do I actually get a line? Well, I just tried integer values of x, but you could try any value in between here. All of these, it's actually a pretty neat concept. Any value of x that you input into this, you find the corresponding value for y, it will sit on this line. So for example, if we were to take x is equal to, actually, let's say x is equal to negative 0.5. So if x is equal to negative 0.5, if we look at the line when x is equal to negative 0.5, it looks like y is equal to negative 4. That looks like that sits on the line. Well, let's verify that. If x is equal to negative, I'll write that as negative 1/2, then what is y equal to? Let's see, 2 times negative 1/2. I'll try it out. 2 times negative 1/2 minus 3. Well, this is 2 times negative 1/2 is negative 1 minus 3 is indeed negative 4. It is indeed negative 4. So you can literally take for any x value that you put here and the corresponding y value, it is going to sit on the line. This point right over here represents a solution to this linear equation. Let me just in a color you can see. So this point represents a solution to the linear equation. This point represents a solution to the linear equation. This point is not a solution to the linear equation. So if x is equal to 5, then y is not going to be equal to 3. If x is going to be equal to 5, you go to the line to see what the solution to the linear equation is. If x is 5, this shows us that y is going to be 7. And it's indeed that's indeed the case. 2 times 5 is 10 minus 3 is 7. The point 5 comma 7 is on, or it satisfies this linear equation. So if you take all of the xy pairs that satisfy it, you get a line. That is why it's called a linear equation. Now, this isn't the only way that we could write a linear equation. You could write a linear equation like, let me do this in a new color. You could write a linear equation like this: 4x minus 3y is equal to 12. This also is a linear equation. And we can see that if we were to graph the xy pairs that satisfy this, we once again get a line, x and y. If x is equal to 0, then this goes away. You have negative 3y is equal to 12. See, if negative 3y equals 12, then y would be equal to negative 4. Negative 0, comma, negative 4. You can verify that. 4 times 0 minus 3 times negative 4, well, that's going to be equal to positive 12. And let's see, if y were to equal 0, then this is going to be 4 times x is equal to 12. Well, then x is equal to 3. And so you have the point 0, comma, negative 4, 0, comma, negative 4 on this line. And you have the point 3, comma, 0 on this line. 3, comma, 0. Did I do that right? Yep. So 0, comma, negative 4, and then 3, comma, 0. These are both going to be on this line. 3, comma, 0 is also on this line. So this line is going to look something like, I'll just try to hand draw it, something like that. So once again, all of the all of the XY pairs that satisfy this, if you were to plot them out, it forms a line. Now, what are some examples of, maybe you're saying, well, isn't any equation a linear equation? And the simple answer is no, not any equation is a linear equation. I'll give you some examples of nonlinear equations. So,
All right. So till now, I think you've understood the basics of linear equations, right? And don't worry, don't worry. We are going to keep raising the level. Okay, this is not a ninth grade only class. What this is a class where you understand the basics so thoroughly that as you build up on it, it becomes very, very easy, right? So, till now, any confusion whatsoever, anybody who is maybe in 10th grade and not understand linear equations well will understand this really well, right? Even if you're in 11th grade or 12th grade, again, graphing an equation is very, very important, right? Okay, all right, we're good here. So, here you can easily see that what is given here, we are understanding how to plot a linear equation on the graph paper, right? Okay. So let's get out here again on the website here. All right, I'm getting out of this and we get back to exercises and we see how we are applying this. Okay, so we get back here and now we are back to the chapter. So, okay, all right. I can see everybody understood this, right? Very, very basic. Any equation where there are two variables and the highest power of every variable, right? So two variables x and y, the highest power is only one. There is no square, there is no cube. Then it is going to be a linear equation. Very simple. And a linear equation in two variables can be graphed on a graph paper on the xy plane and it comes out to be a straight line. Yes, very good. Now, once you understand the basics that a linear equation in only x and y can be a straight line in a plane, xy plane, you will understand what builds on top of that, which is a linear equation in three variables, x, y, and z, will be a straight line in space, right? And then you will be able to figure out which plane is the linear equation in actually, right? So you'll be able to figure out the plane of that linear equation as well, which we do in 11th grade, don't we? Coordinate geometry. All right. 3D geometry to be specific. So understanding how we define the plane of an equation is very, very important. Understanding how we define the plane of a straight line is very, very important. But for that, it's very, very important to understand how you plot a straight line in the first place, right? Exactly. Okay. All right. Let's get to these questions now. All right. Now, I have heard a lot of students say that, ma'am, we understand the concepts, we understand everything, but word problems make us a little, it's a little difficult, right? So, how many of you over here are a little bit scared or a little bit skeptical in actually approaching word problems? Tell me. How many of you have issues with word problems? And don't lie to me, don't lie to me. Come on, be honest here, be honest here. Yes? Okay, all right. Let's get to linear equations, word problems, and quickly tell me what your answers are so that we move on from here very, very quickly. Okay? Yes, I can see that. 143 FF, Sahendra. Yes, you said me. Devjani, Sarita. Yes, I know. Let's go and tackle the word problems now. Okay, so here we are. Are you guys ready? Let's go. Here I have the first problem. Okay. And what do you see here? This problem is based on, again, linear equation. We have to figure out what it means. Rachel is a stunt driver, it's written, right? She's escaping from a building that is about to explode. Oh yeah, that is what a stunt is about, of course. Now, the variable D models Rachel's distance from her exit in meters T seconds after the cameras began recording the stunt, right? So she's running away from a building, and the distance of Rachel with the building is given by this equation. D represents the distance. So quickly tell me, who can tell me the answer first? What is Rachel's speed here? Come on. Quickly tell me the answer here. What is Rachel's speed here? Okay, I can see Shureshwar is from JNV. All right, all right. Okay, JNV Khargon, Seema. Awesome, welcome. Okay, JNV Rudrapur. Okay, Masti with Child. What's your name? That's a cool username, by the way. Okay, tell me, what is the answer here? Okay, Rajiba gave me the first answer. Rajiba is the first person to give answer here. Okay, all right, 135. One says 182. Okay, and what else? What else? What else? Come on, give me an answer here, guys. I know you guys are big guys, but what is the answer here? All right, D is equal to minus 38T plus 220. Correct. D is equal to minus 38T plus 220. And this tells you about the distance. As you can see, as time increases, distance decreases. That means distance is reducing because she is running away with a particular speed, right? So, can we find the difference in distance? And that will give us difference in distance for 1 second. That will give us the speed, right? Now, a lot of people are giving, oh, Dilip gave me 38. All right, a lot of people are giving me 135 here, but you guys should check your answers a little bit. Are you sure it is 135? Exactly sure? Come on, come on, come on. Are you sure it is 135? No, solve yourself. Okay, let's check, let's check. So many people are giving me 135 answers. Let me just put 135. Okay. So if I put 135 here, what do I get? What do I get? Ooh, not quite yet. Not quite yet. No, no, it is not. It is not. So what do we do? Come on. Yes, exactly. Devila, correct. Sthiti, lucky. 38. 38 is the answer. Why? Why is 38 answer? Okay, let's see. So the point here is that she is moving away and the variable part of this equation, see, it's a linear equation in two variables. There is a variable part and there is a constant part. Constant part does not change, right? So understand the basics here. Okay. Now, here we have D in terms of T. D is a function of T here, right? And T minus 38T is the variable part. This is the variable part. And 220 is the constant part. This is the constant part. And in any function, the constant part will not change with time, right? The variable part will change. So the part that is changing in distance is due to speed. That means the part that is changing in 1 second is how much? Change in 1 second is equal to, yes, 38 meters. And that is why the speed is 38 meters per second, right? Now tell me, understanding this concept, again, it's very basic of math, class independent. Whichever grade you are in, 9, 10th, 11th, 12th, you should be able to understand a simple linear equation and a simple linear function, right? So I see that the answer over here will be 38, correct? How many of you understood that? Here, D in terms of T is in two parts. The variable part is the only thing that's going to change. The constant part is not going to change, right? Understood, everybody? So, yes, let's go ahead and write our answer over here now. So, I'm going to change my answer now. Yes, it's not 135, it is 38. And now we go for a check. Awesome. All right. Okay, correct. Now, here, once we answer the question, sometimes you think, oh, okay, I got a little bit correct or incorrect for that matter, and you want to see step-by-step solution. If you want to see step-by-step solution anywhere, here is where you can see it from. There you go, step-by-step solution available for every question out there, in every exercise, in every quiz and everything, right? Okay, okay. Khatun says, explain once more. Sureshwar says, ma'am, once more. Okay, so here I'm going to build a very, very basic understanding for you. Okay. Let me clear this out very, very quickly and then we will bring. Okay. I'm clearing this out now. All right. Now, the basic idea here is that although the question came in linear equations, you see that d is equal to, oh, my pen, here we go. D is equal to minus 38t plus 220. This is the relation that is given to us, right? Okay. This is, yes, technically a linear equation in two variables where d is a variable, that is the distance, and t is a variable, that is the time. Okay, that is clear. Now, d is written in terms of time. That means d is the dependent quantity. This is dependent. And t is independent. T is independent, right? And whenever independent quantity changes, t is going to change on its own. Who controls time? Nobody, right? So time is going to change on its own, and as time changes, distance changes also. So if we want to find out speed, which is nothing but change in distance, that is displacement, right? Change in distance per unit time, that's exactly what we want. That means we want change in d per unit change in t, correct? Very simple. That's the basic of understanding the dependent variable, which is dependent on the independent variable, right? Okay, all right. So here we have this part, that is variable part. This is the variable part, and this part is the constant part. So if you calculate, now you can calculate and also see, right? At t is equal to 0, at t is equal to 0, what is the distance? Distance is equal to 220, correct? At t is equal to 1, what is the distance? Distance is equal to 220 minus 38. 220 minus 38, which is equal to how much? Which is equal to, yes, 200 minus 18, which is 182. Okay. Now, do you see the change? She ran by how much? That is the change. And the change in distance, change in d is equal to how much? 220 minus 182. That is equal to 38. That's it, right? Very simple. And you can solve it this way. You can solve it this way and calculate, or you can just look at the function and see the variable part and say, yeah, that is the only part that's going to change. That's it. I don't need to solve anything here. Does that make sense? Yes? All right. All right. Let's go. Let's go. Let's move on to the next one now. Here we go. Next one, next one, next one. Now, tell me very quickly, what is the answer to this one? So, a big ship drops its anchor. Here it's given that a big ship drops its anchor. The variable L models the anchor's elevation in meters relative to the water surface t seconds after the ship drops its anchor, right? So, L is basically giving us anchor's elevation. Elevation means height in meters relative to the water surface t seconds after the ship drops its anchor, correct? So the ship is dropping anchor. It's just going to go down, right? The anchor is not going to fly up. We know that. So there is going to be a reduction in L. All right. Tell me very quickly what the answer comes out. Oh, Rajni gave me an answer. All right. Rajni said 24. Kumar Gaurav said 75. Okay. Who else? Who else? Ansuman Nayak. All right. 26. Okay. Your answer is 26. Kiran, 24. Bhavna, 24. Rajni, 75. Okay. Chiku, 24. Now, which answer should I put in? Come on, come on, come on, come on, come on. What is it? What are your answers coming out? Which answer should I put in here? Okay, 24, 24, 24. A lot of people are giving me 24. Okay. Oh, 2.4. All right. Some are giving me 2.4, 2.5. Okay. So many different answers. Let's check. Let's check. Let's put it one by one. So we have to find out the elevation in meters relative to the water surface. T seconds after the anchor drops. What is the initial height of the anchor? Initial height of the anchor is going to be the height at T equal to 0. Initial means T equal to 0. Correct? So, initial, every time in every varying situation, whenever a situation changes, varies, initial is always at T equal to 0. All right? That is a standard, that is a basic that we always apply wherever we apply math, physics, chemistry, anywhere. Okay? All right? Initial means T is equal to 0. So what do? We substitute T is equal to 0. That's it. I know. I see. You guys got it. Okay. Yes, I can see. Everybody's giving me 75 now. All right. Suchitra, Jyoti. All right. All right. Let me just see. Parmesh. Um. Oh, Suchismita, Manamuni. And okay. So many different people. Yes, I can see that. And yes, 75 is the answer. At T is equal to 0, L is going to be equal to, the T portion will become 0. The variable part becomes 0. 0 plus 75. That is nothing but 75 meters. Right? Exactly. Now tell me you understood. The basic idea here is that initial means T equal to 0. That's it. Okay? All right. Let's get back. Write the answer. 75. Here we go. Check the answer here. And what do we see? Correct. Okay. All right. So the idea here is that, again, see, when you watch a video and you go solve the questions in the exercises, you get streaks and you get badges and you remain motivated to solve because, well, fun. Math is fun, right? So there you go. Okay. Yes, we will go to class 10th also, and then we will move on to 11th also and 12th also. Don't worry. Let's go to this question and then we move on. Okay. So this question first. Next question is, are you ready? Are you ready to answer? Yes. Okay. During the cold winter months, a sheet of ice covers a lake near the Arctic Circle. At the beginning of the spring, the ice starts to melt. Yes, the ice starts to melt. So, the variable S models the ice sheet's thickness in meters T weeks after the beginning of the spring. All right. So, T is in weeks, and each week the ice is going to melt. So, T reduces. Right? Okay. S is given like this: by how much does the ice sheet's thickness decrease every 6 weeks? We're talking about reduction in ice sheet thickness every 6 weeks. Correct? So I can see so many different answers. All right. Aditya is giving me 2.4. Rajni is giving me 4. Sushant is giving me 0.25. All right. Different people, different answers. Kumar Gaurav is giving me 2.70. Okay, Devila is giving me 1.5. Again, what are we doing here? Think about it. What do we want? We want the reduction in ice sheets thickness. That means we want the change. Change in ice sheets thickness. Correct? We want change. So we will look at the part that changes. That's it. We want change. So we will look at the part that changes, not the part that is constant. Correct? Okay. So S is equal to minus 0.25 T plus 4. All right. And this is the variable part. This is the variable part. This is the constant part. So which do we look at? We look at the part that changes because we want the change. We look at this part and not this part. And then we go for, all right, if it changes by 0.25 in 1 week, then in 6 weeks, how much is it going to change by? In 6 weeks, it's going to change by 6 into 0.25. Simple, right? 6 into 0.25, that is 1.5. Very good, Jyoti, Kumar Gaurav, and yes, exactly. So, how much is this? 1.5 meters is the answer. All right, is it the answer though? Let's check. All right, should we check? Tell me, should we check? Yes. Okay, all right. Are you guys getting the answer? Okay, okay. I will ask you. I will ask you. And then we will put 1.5. Okay. All right. Go for a check. Awesome. See? We got it. Did you guys get it? So, what is the basic funda here? The basic funda of the entire relations and functions and equations is that if you want change, then look at the quantity that changes. If you want the overall value, then look at the entire value. Does that make sense? Yes. If you want change, look at the quantity that changes. If you want the entire value, look at the quantity and find the entire value. And initial always means t equal to 0, right? Okay, that's it. Is basic say, with this basic, you will be able to solve a lot of different types of problems. Okay. All right. All right. Let's move on. Let's get to the next one. Okay. By the way, for all the folks here who want me to speak in Hindi, we have ongoing parallel sessions in Hindi channel also. All right. Not just in English channel. We have parallel sessions happening in Hindi channel also. I come there as well and we talk about the same things here. Okay. So if you're comfortable with English, come to this channel, English channel of Khan Academy. If you're comfortable with Hindi, come to Hindi channel. All right. Got it? Yes. Okay. All right. Let's move on. Now, let's go after this question. Just after this question, we will go to the next, which is its equivalent in 10th grade. Okay. So we are going one grade up like that. All right. Harry took out a loan from the bank. Are you ready? Are you ready? Yes? Okay. Harry took out a loan from the bank. The variable D models Harry's remaining debt in dollars T months after he took out the loan. So, D is given as minus 200T plus 9,000. How much does Harry pay back each month? Okay. So, D is given as minus 200T plus 9,000, right? And that's how loans work. I mean, you have to pay back every month. And here is his loan in terms of time t, right? His remaining debt. So what's the answer? How much is he paying every month? Oh, yes, I can see everybody's answering here. Okay. Art of the Craft says 200. Kumar Gaurav says 200. Devila says 200. Ayush says, oh, 800. Okay. No. How much is he paying back? 200. Okay. Okay. A lot of people are saying 200. Some are saying 900. Okay. Okay. Hmm. Are you guys ready? Are you guys sure? Some are saying 2000. Are. No. Okay. Yes. So the idea here is again, how much does he pay back? When he pays back, the remaining amount changes, right? So, say for example, he had a total of $9,000 of debt initially, because at t equal to 0, it is 9,000, right? Every month, he pays some amount back and the loan reduces. So, how much does he pay back? In 1 month, how much is the loan reducing? See, at t is equal to 0, d is equal to 9,000. At t is equal to 1, d is equal to 9,000 minus 200, which is how much? 8,800. So, how much did it reduce by? It reduced by 200. Why? Because he paid it back. That's it. So, what's the answer? 200, right? Very simple. So, answer is he is paying back $200, right? Okay. Do you see that? The change that happened, change is equal to the amount he paid back. He paid back, which is equal to how much? The difference between 9,000 minus 8,800, 9,000 minus 8,800, which is equal to 200. Does that make sense? Yes, exactly. And you don't even have to calculate this. You can just look at the question and figure it out. How do we just look at the question and figure it out? Think about it. Here I go. and I say, this is the relation, right? This is the D is equal to minus 200t plus 9000 linear function. And this is the variable part. This is the constant part. Variable and constant. Now, I want to find out how much he pays back. That means I want to find out how much the loan changes. For change, I look at the variable, right? And what is the variable part? Minus 200t. That means for every 1 month, the loan reduces by 200. That's it. For every 1 month, loan reduces by 200. You can just look at this and figure it out, right? Does that make sense? So no need for all the calculations. Does that make sense? Yes, 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 yes. How many of you got the concept really well and tell me here? Come on. Tell me if you understood this. Yes? Okay. Adarsh says yes. Raman says yes. All right. Ayushi says yes. Okay. Shushi. Okay. Awesome. 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 Now that we have understood this basic concept of variable parts and constant parts and how to identify them in real life situations, yes, we go back and now we go to the next upgrade. Okay? All right. Let's go to the next upgrade now. Are you guys ready? Okay. So here I go back to the explore page, and this is the explore page where you can basically explore, right? So let me tell you a little bit about this also, that as soon as you have an account, you come to the Khan Academy website and you can explore everything out here. And as you can see, there is mathematics for NCRT, mathematics for state boards, right? Mathematics in different languages. We have the entire website in Hindi, in Marathi, and in Orissa, and so many different languages. All right. And what you have is you can access everything, anything that you want. There is nothing behind a paywall. That is the best idea out here. And what we are trying to do from Khan Academy is provide quality, top quality education for every child out there without any fee. All right. Free education for all. That's the idea. Okay. All right. All right. All right. Now, with this, let's go and let's get to grade 10. Okay, are you guys ready? Let's go. Let's go. Explore page, grade 10. All right. And now we come to, here we go, pair of linear equations in two variables. Pair of linear equations and graphical method of a solution of linear equations. Okay, let's go ahead and let's take a look at a very cool video out here. Okay. Linear equations word problem that is made by Sal Khan here. Okay. Sal Khan, who is the founder of Khan Academy. So let's go ahead and take a look at this. Now, I am going to play this video, and when I play this video again, I am not going to speak when I play this video. Okay. You know the drill by now. So the drill is that when I play the video, I am not going to speak. You will be able to listen to the entire video, but as soon as the video starts, you tell me if you can hear everything. Okay. If the video sound is right. All right. Okay. Are you guys ready? Okay. I can see that here we have, oh, so many people. I can still see JNV people are winning. You know, more people from JNV than OAV. Okay. Okay. OAV people, you gotta spice it up here. I teach you and I see the charts, and JNV people are kind of winning. Come on, OAV people, spice up. Yes. All right. All right. So let me play the video. All right.
Is less than 220. Let's see, that's Omojobi is 220 centimeters tall. He wanted to fill up his pool so that the water level would be as high as he is tall. So that the water level, I guess, would be 220 centimeters tall. The water level rose by 6 centimeters each minute and reached the desired height after 20 minutes. Graph the pool's water level in centimeters as a function of time in minutes. Well, they do tell us one interesting thing. They say that the water level reached the desired height after 20 minutes. And we know what the desired height is. The desired height is to be as tall as, or to be as deep as he is tall, or as high as he is tall, and that is 220 centimeters tall. So they're telling us essentially that the water level of the pool after 20 minutes is 220 centimeters. So we can plot that. So after 20 minutes, so we could plot that point right there. After 20 minutes, we're at 220 centimeters. So we would be right there. Now, the other question is, where would we put this point? We needed another data point in order to define a line. And so let's see, they tell us that the water, you might be tempted to say, okay, maybe the water level was at 0 to begin with, but they didn't tell us that. Maybe when he started filling the pool, there was already some water in there. So we have to be a little bit more careful. But they do give us some information. The water level rose by 6 centimeters each minute. It rose by 6 centimeters each minute. So at 20 minutes, we know we're at 220. And if we rose 6 centimeters each minute, where would we have been? Where would we have been, let's say, 10 minutes ago? So where would we have been at time 10? So every 10 minutes, if the water level is rising 6 centimeters a minute, it would be rising 60 centimeters every 10 minutes. So 10 minutes ago, we would be 60 centimeters less. So 60 centimeters less than 220. Let's see, that's 20 centimeters less. That's 40 centimeters less. That's 60 centimeters less. So if you go back in time 10 minutes, you would be 60 centimeters shallower or less high. And 220 minus 60 is 160. Now, I think I'm done. I think this describes it. Now, let's see if it makes sense. This is telling us that at time 0, before he even started filling it, there was already 100 centimeters in his pool. And then after 20 minutes, he's done. And is that consistent with 6 centimeters a minute? Well, based on this, it took him 20 minutes, to get to 220, but that's an incremental 120. To go from 100 to 100, to go from 100 to 220 is 120 more centimeters. So in 20 minutes, he got 120 centimeters. Well, 120 centimeters divided by 20 minutes is 6 centimeters per minute. So this is looking good, and we got it right.
All right, all right. So now, with this question, how many of you understood, by the way, what was happening here? Yeah? Everything clear? Everything clear? What happened? There was this question that was solved using graphs, right? So let's go ahead and understand a little bit more about it. All right? So here we go. Grade 10, pair of linear equations, and graphing linear relationship word problems. All right? Okay. Okay. All right. Sahindra says, "Oh, you're from IIT Roorkee." Okay. What? I am so glad that you're here. You're just interested, huh? Okay. Okay. All right. I'm from Kharagpur. But yeah, I know people. I know people from Roorkee. So all right. Let's go. Let's go. Graphing linear relationship word problems. Here we have how to graph linear relationships, right? So this is the first question. Guys, come on. Let's go ahead and solve this. Tell me, what is your answer? And you can see, okay, so about the graphical solutions, right? The thing is that I love these interactive graphs. Did you know that all of these are interactive graphs? And when you actually go for exercises, right, because after this session you will be able to go towards the exercises, the kind of, yeah, because every session after that you have to practice, right? So these are practice sessions, and you will find the link for the exercises in the description. Okay, and when you go to these exercises, you will be able to see that you will be able to take these graphs, like, see, I can interact with them. I can make this line anywhere and see how fun this is, right? Okay, all right. Now, let's solve this question in the fun way. So, tell me, Wilbur landed his plane, causing it to descend at a rate of 0.2 kilometers per minute. So the plane is descending at the rate of 0.2 kilometers per minute. Okay. He reached the ground after 15 minutes. Graph the relationship between plane's elevation relative to the ground in kilometers and time in minutes. Right? So first things first, we have to find out the coordinates here. Right? Okay. Yes, yes, yes. Kumar Gaurav gave me a couple of coordinates. Awesome. Quick of you. So 0, 3 and 15, 0. Anybody else? Anybody else giving me coordinates here? What do we need here? We need 2 points. 2 points that are going to satisfy this equation so that we can plot them over here, right? Exactly, exactly. So let's start with 2 points. Here we have to graph the relationship. Wilbur landed his plane, causing it to descend. Rate of descent is 0.2 kilometers per minute. 0.2 kilometers per minute, right? This is the rate of descent. And the ground reaches, he reaches the ground after 15 minutes. So after 15 minutes, he reaches the ground. All right. Now we are talking about elevation relative to the ground. That means after 15 minutes, if he landed at 15 minutes, then what is the elevation now after landing? Zero, right? Exactly. So now I can say that time is on x-axis. So at t is equal to 15, at t is equal to 15, y, which is in height, right? Height, which is in y-axis, will be how much? Height is equal to 0, right? So now I have x is equal to 15, y is equal to 0. That means I have exactly 15 comma 0 as 1 point, right? So 15 comma 0, where is that? Where is that? Where is that? X is equal to 15, y is equal to 0, x is equal to 15 right here, and y is equal to 0. Oh, this is 15 comma 0, right? And the next point will be, that he started with a descent of 0.2 kilometer per minute, and after 15 minutes he has descended. So where was he? He is descending, he's coming down at a rate of 0.2 kilometer per minute, and he's down after 15 minutes. So what is his initial height? Initial height will be equal to, h is equal to exactly 0.2 multiplied by 15. That is equal to 3, right? Okay, 3 kilometers. And this, we have the other coordinates. That means at t is equal to 0, at t is equal to 0, we have height is equal to 3. That means we have x equal to 0, y equal to 3, 0 comma 3. Yes, 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 very good. 0 comma 3 right here. And that is the second point. So now I'm going to go ahead and plot these 2 points. I have 2 points right here. So 0 comma 3. X is equal to 0, y is equal to 3. This is the point, right? Exactly. 0 comma 3, 15 comma 0. We go ahead and we check the answer. Should we check? I can see a lot of people have got the answer. We have, all right, Imtiaz, Lucky, Lisa, Srishti, Malesh. Yes, yes, everybody has got the answer. Okay, okay, let's check. Awesome. Good to go. Good to go. Yes. Those of you who got this answer right, awesome job. And those of you who got a little bit stuck, I hope you've understood this really well, right? The idea here is to make sure your concepts are crystal clear. So let's go ahead and move on to the next one. Are you guys ready? Move on to the next one. Okay, here we go. This is the next one. Graphing linear relationships. This is the next question. Sean tried to drink a slushy as fast as he could, right? Sean tried to drink a slushy as fast as he could. He drank 5 milliliters of slushy each second and finished all the slushy after 50 seconds. All right, what's happening here? Graph the relationship between amount of slushy left in the cup and time. Okay, okay. So tell me the 2 points. Anybody here can tell me the 2 points? We need 2 points, right? As soon as we want to graph a linear equation, the only thing we need is 2 points. That's it. So, all right. Sahendra says, ma'am, teaches coordinate geometry. Yeah, we'll come to that. We'll come to that. You have the schedule, right? I showed you the schedule. So we'll come to that. Okay. All right. All right. After this question, I'm going to show you the schedule again. So here we have 5 milliliters of slushy per second being drunk, right? So he is drinking 5 ml per second and he's finishing. So this is the rate and he's finishing. So at 50 seconds, right? Finishing at 50 seconds. So how do we do this? We go ahead and say that after 50 seconds, the slushy remaining is 0, right? After 50 seconds, the slushy remaining is 0. That means at x is equal to 50, y is equal to 0. So here we go. At x is equal to 50, y is equal to 0, right? 50 seconds, x-axis, time. So time is 50 seconds. That means x is equal to 50. So 50 comma 50 comma 0 is 1 point. Okay, that's 1 point only. So we go ahead and plot that. Where is 50 comma 0? Okay, let me go a little down, and now we have this graph again. So where do we put it? Where do we put it? All right, 50 50 50 here, 50 comma 0. That's the point. Yeah. All right, everybody got this? Now the next point. The next point is, well, what happened at t equal to 0, right? So it's a very, very good idea to look at points that are at the end of it, right? Extreme points. So here we have the rate at which slushy is being drunk is 5 milliliter per second. So if he took a total of 50 seconds to drink, then how much was the original slushy? Original slushy would have been, again, 5 ml in 1 second. So in 50 second, how much? 5 into 50, right? That's it. So what do we have here? 250. That was the volume in the beginning. In the beginning means t equal to 0. So 250 ml at t is equal to 0, right? That's it. Very, very simple. So 250 ml at t is equal to 0. That means I have 250, t is equal to 0 right here. And now we have 2 points, right? Here we have 0, comma 250 and 50, comma 0, right? Exactly, exactly. Yes, Radhe, you're correct. So now we have Ayushna. Very good, very good. Ayush, Mithilesh, Sabira. Okay. Sarita. All right. I can see that you guys have got the answers. So now we go ahead and check ours. Are you guys sure though? Should we check? Yeah? Good? Good to go? All right. We're locking this and we're checking this. All right. All right. We're good to go. Okay. Correct. And if you want to see the step-by-step solution, you can come here and see the step-by-step solution, right? This is the entire step-by-step solution. So the idea here is, again, you will see that all of these questions in the exercises have something that I love. Okay, one feature, that is, even after step-by-step solution, if you still don't understand, if you still feel that, oh, I did not understand this, I need to go back and revise it again, or you have doubts, and then you go ahead and ask your friends and ask your teachers and ask everybody, right? What you can do is you can go down, and here after every question you will find a suggested video. Okay, so once you have the suggested video, you can directly go to that suggested video and that will clarify the concept that the question is based on. Okay, and again, that is a very, very useful and efficient feature. All right, because we don't want to be wasting time running after people with our doubts, right? Yes. All right, with this, I hope now, oh wow, look at the time. We had a lot of fun, right? Okay, I had a lot of fun explaining all of these to you, and especially the interactive graphs. So with this, we will go ahead, we will wrap up, and we will wrap up slowly. Don't worry about it. So here we go. We go back to the Explore page, and you guys tell me, You have the exercises, you have the links to the exercises, so do not forget to do them properly. Okay, it's just 4 questions. So for ninth graders, you can go to the first link of the exercise, that's for ninth grade. Second link is for 10th grade, then we have a link for 11th grade, then we have a link for 12th grade. All right, so you only do the exercise that is for your grade. If you want to do the exercises for other grades also, out of curiosity, because well, we are all curious, yes, you can do those also. And we will be meeting same time next week. Until next time, be happy, have loads of fun, keep loving math, and happy learning. Bye bye.